So 5.6 is using multiplicative inverses to solve equations. Well, the multiplicative inverse of a non-zero number is just the number's reciprocal. So it's another way of saying, like from the last section, the multiplicative inverse of 3/5 would be multiplying by 5/3, because 5/3 is the reciprocal. And we can use this to solve one-step equations. So this is kind of what you've seen before. And what you normally probably would have done is multiply by 15 on both sides, and then go back and divide by -4 on both sides. But now that we know how to multiply fractions, there's something easier we can do. And instead of having to do two steps, we can simply multiply both sides by the reciprocal of what's associated with x here. So in this case, -15 over 4 would cancel this and this out. And as long as we do the same thing to both sides, we keep it all balanced. So now x is simply equal to -10 times -15 over 33 times 4. And you know how to do this already because this is just what we've done in the previous chapter. Let's first divide out common factors. So in this case, -15 can be divided by 3, and so can 33. So we're left with 11 and -5 on top. 4 can be divided by 2, as can -10. So we're left with -5 times -5, which is 25, divided by 11 times 2, which is 22. And then we can go ahead and we can make this a mixed number, so 25 and 22. Well, we know it's 1, and then we have a remainder of 3, 22. I'll give you another example of this later. I'll let you practice one on your own. But the main thing is now, we're still doing the same stuff we've learned before. We're just using it to solve for x. So what happens if there's two steps? Well, two steps gets a little trickier, because here we have both addition and multiplication. The first step you're going to do, just like if you have another problem, is you're going to first subtract 7/20 from both sides. And we can do that because these are like. So the one on the right side of the equation and the one on the left that have to do with addition and subtraction both have 20 as the denominator. If they didn't, we would have to make sure they're like. But let's subtract 7/20 from both sides. So we're left with 8/15 x equals, well, 13 minus 7 leaves us with 6 over 20. And now it's just like the previous slide. Now we can just multiply by the reciprocal, or the multiplicative inverse. These cancel here, leaving us just with x. And now we have 6 times 15 over 20 times 8. Let's go ahead and simplify this. So 20 and 15 both get 5 into it. 4. We can divide this by 2, leaving us with 3. And this also by 2, leaving us with 4. So we're left with 9 over 16. So that's simplified. So x equals 9/16. So I want you to do is now try one on your own. So it's a very similar problem. So press pause now and give it a try. Example 3. So I'm going to walk you through this. I already did this problem ahead of time, but here's a two-step equation, but it was given to us as a word problem. So So you were training for a marathon. Currently, you can run 12 miles. You increase the distance you run on your long run day by 7/10 of a mile each week. So each week, you increase this length of your run by 7/10 of a mile. They want to know how many weeks will it take you until you can run 26 miles. So the verbal model is the current distance you can run, which is 12 miles, plus your weekly increase, which is 7/10, times the number of weeks. Well, that's our x. We don't know what that is. So you could say x or w to get our distance goal, which is 26. So you can plug those in. I ended up using w. And the first thing you need to do is subtract the 12 from both sides, because that's not the one associated with w. So you can easily do that, giving us 14. So you're left with 7/10 w equals 14, but we're going to multiply by 10 over 7, which is the reciprocal, ending up with 14 times 10 divided by 7, which is 20. So it takes you 20 weeks before you'll be able to build up and run 26 miles if you only increase by 7/10 of a mile each week. That was a little complicated, but if you really just got the problem written down, you should be able to do this. So that's all for today. We'll do an example word problem in class tomorrow so you can practice, but I hope this lesson went well and you're able to follow along and realize how you can use all the things you've already learned to now solve for a variable in one or two-step equations.